All right, think about this for a second. Solar panels. But panels that don't just need sunshine, what if they could actually pull energy from, say, a rainstorm? Sounds a bit like science fiction, maybe. Well, today we're doing a deep dive into something pretty fascinating: rain-powered solar panels. We're going to unpack how this tech works, look at some, well, frankly, surprising benefits, and figure out why a place like New Jersey might be a perfect spot for it. We're digging into some really cutting-edge research here.
Right.
So for anyone listening who's hearing rain-powered solar for the first time, how does that even begin to work? It almost sounds, well, too good to be true.
Yeah, it's a clever concept. What they do is merge traditional solar tech with something called triboelectric nanogenerators.
Hmm?
A 10-eng for
Good
short.
term ends. Okay.
Think about like static electricity,
Yeah.
rubbing a balloon on your hair. That's the basic idea, the triboelectric effect.
Okay.
So here, the kinetic energy, the motion of a raindrop hitting the panel, creates a small electric charge. It is liquid-solid contact electrification. And that means on cloudy days, or when it's actually raining times, when normal solar panel efficiency really drops, these panels can actually supplement the power output.
Wow. Okay. That alone is a game changer. But what else? Are there other advantages? Maybe less obvious ones?
Oh, definitely. The genius part is how it tackles some of traditional solar's weaknesses. So first, yes, dual energy harvesting, power from sun and rain, more consistency.
Right.
But get this, the rain naturally washes dirt and debris off the panels, so they're essentially self-cleaning.
No way. That cuts down on maintenance, I bet.
Exactly, big cost saver there. And critically, the rain cools the panels down. This acts like built-in temperature regulation.
And that's important because panels get less efficient when they overheat.
Precisely. Overheating is a major factor in efficiency loss for standard panels, so the rain actually helps them perform better in some ways.
So it's generating power and doing its own chores. That's pretty appealing, especially if you've ever had to clean panels on a roof. But my first thought is still, rain means clouds, less sun. How big a boost can the rain really provide? What are the big engineering hurdles here?
That's a fair question.
And why New Jersey? What makes it such a specific, good test case?
Okay, so the main challenge is definitely the low energy output per single raindrop. It's tiny.
Right.
So you need really advanced designs, clever structuring of these 10 layers to actually gather a meaningful amount of power. Scale is key. And of course, integrating TENGs adds cost and complexity to the manufacturing process. It's not just a standard solar panel anymore.
Makes sense.
Now, New Jersey, it's almost like a perfect natural lab. The state gets about 48 inches of rain a year. That's significantly higher than the U.S. average of around 38 inches.
Lots of rain.
And lots of cloudy days, roughly 117 per year. Plus, you have to consider the storm risks, especially along the coast, but increasingly inland, too. Hurricane-force winds have actually doubled in frequency in the region since the 80s, so these panels would need to be really robustly designed to handle that kind of weather.
Okay, robustness in dealing with lots of rain and clouds. Now, the money question. What does this mean for, our wallets? What's the cost picture look like? And is this just theoretical, or has anyone actually built these things?
Well, let's look at standard solar first. In New Jersey, a typical 5-kilowatt system runs you about $13,142 before any incentives. After the federal tax credit, maybe closer to $9,199.
Oh.
Adding these rain harvesting tanks, that's definitely going to increase the upfront cost because of that extra complexity we talked about. As for real-world examples, yes, researchers in China have made some good progress. They developed something called TENG panels. Yeah, a specific sort of advanced design. They've shown it's possible to link multiple TENG units together to boost the output. But scaling that up to generate megawatt levels of power, that's still a major hurdle they're working on.
I see. So potential, but still needs development for large scale. Bringing it back home then to New Jersey, what kind of applications could you really see this being useful for there?
Well, given New Jersey's climate, lots of rain, frequent clouds, you can see residential buildings really benefiting. Getting a more consistent power supply, even on those gloomy days when standard solar just isn't doing much.
Smoothing out the power curve.
Exactly. And think about coastal areas. They're more vulnerable to storms, power outages. These panels could act as a vital backup power source during long, cloudy stretches, when the grid might be stressed or down.
That makes a lot of sense. So if we compare them side by side.
Quick comparison. Traditional solar efficiency can drop, 10% to even 50% in rain. These rain-powered ones get supplemented by rain. Traditional panels need cleaning. These are self-cleaning. That's a pretty stark difference.
It really is. It feels like these rain-powered solar panels offer this dual promise,
Mhm.
especially suited for a climate like New Jersey's, turning, well, bad weather into an energy source.
Which, raises a bigger question for all of us, really. As our climate keeps changing, how do we need to think differently about reliable energy? What role could these kinds of unexpected, maybe dual-purpose solutions play in building a more resilient, sustainable energy future? Something to think about.